Hello, my name is Adrian Rodriguez, and this is Project 3 for Dr. Khan, which is NPN transistors and logic gate. So first, we're going to start off with our first NPN transistor logic gate circuit, which is going to be the AND logic circuit. So we start off with our power source, which is going to be my computer, connected to the microcontroller, connected to the breadboard, and we're also going to be utilizing 1 kilo ohm resistor, 2 NPN transistors, and 1 LED. Now here is our go circuit for our AND logic circuit. Now we see that the LED light is still off. That is because we still haven't applied our 2 switches, which is our 2 circuit cables, to our 2 NPN transistors, collector, and base terminals. Now in AND logic, the way it works is it requires both switches to be on in order for the light to turn on. So we're going to turn on the first switch by applying the cables to the collector and base terminals. So now we have one, but as you see, the light is still off because we need both the switches to be on. So that's just one switch, so we're going to turn on the other switch. And then with this, the light should turn on. So with this, we have turned on our light because both switches are on, and that completes the AND logic, because in AND logic, both switches need to be turned on in order for the light to power on. As if one switch was to turn off, it would turn off the light because it requires both switches to be on in order for it to work. Now the next circuit we're gonna build is the OR circuit. Let me build that real quick because I don't know how to do all that fancy YouTube editing, so you're gonna see me build it here live. So in the OR logic circuit, it requires that they be in parallel. So the 2 NPN transistors have to be in parallel. So in the first one, they were in series. And now in this one, they're gonna be in parallel. So AND logic is in series and OR logic is in parallel. And so we're just gonna be moving our components around a little bit. And so the way this OR logic works is it only requires one of the switches to be on. So either the first switch or the second switch could be on, and the LED light will turn on, as it only requires one switch to be on. Okay, so here is our go circuit for the OR. So now here we have our 1 circuit cable, which is going to serve as the switch. So either if we apply, so we're going to apply the switch to the first NPN transistor by putting it to the collector and the base, and we're going to see that the light's going to turn on because one of the switches has turned on, and it meets the OR logic of just one being on. So like you see, so we put it in, and the light turns on because one of the switches is on. If we take it out, no switch is on, so the light is off. But let's apply it to this switch. Sorry, I'm a little blind. So we apply it to this switch, and the same thing, the light turns on because it meets the OR logic of at least one of the switches being on. And then if we were to apply it to both of the switches, the light would still remain on because it only requires one to be on. So as long as one's on, the LED light will turn on. So that is our OR logic. As long as one switch is on, the light will be on. And now we go to our final one, which is our NOT logic circuit. Now this logic circuit only requires 1 NPN transistor. So we could actually remove 1 NPN transistor because the NOT logic gate only requires 1 NPN transistor. So we could keep everything the same with our 1 kilo ohm resistor and all that, and we just move some things slightly over. You're going to see a little difference in the NOT logic skeleton circuit right now. And here's our NOT logic skeleton circuit. Now, the difference between the NOT logic, and the other 2 previous AND and OR logic is that in the skeleton circuit for NOT logic, the light is on. Now, the reason why the light is on is because the non-logic circuit works in a different way. The switch, once we turn it on, works to invert the input signal. So once we turn this switch on, it will actually turn the light off. So the non-logic gate works to invert the input signal. So once we put this switch into the NPN transistor switch, it will turn it on, causing the light to turn off. So we're gonna go right here. So we're gonna put it into into the collector terminal, and then into the base terminal. And you see that the light has turned off. Now that is a function of not logic gate, because as soon as we turned on the switch, it inverts the input signal and it caused the light to turn off. So when the switch is on, the light is off. And when the switch is off, the light is on. Thank you so much. That has been my 3 applications of the circuits and, or, and not logic circuits. And then this has given me an idea on how they work in real world applications. You know, for example, the not logic gate is used in street lamps. When the sun is out, the light is off. And then and logic can be used in cars, because in order to turn on the car, the key needs to be in the ignition and your foot needs to be pressed on the brake. And then for or logic, it could also be used in a car again, as when you have a flat tire, it sends you a message when any one of the tires is low, not when all of them. So that's an example of or, because when just one of the tires is low, the car is going to send you a message. So these are just examples of how we use these logic gate circuits in everyday life. And yes, thank you so much.